So the most important thing you want to remember for all these problems that have negative exponents or down here fractional exponents is you do the same exact power rule, right? So you're still going to follow the same idea. So if we have f of x equal to x to the n, we already know from the power rule that the derivative, right, is going to be nx to the n minus 1. So just bring the exponent down, multiply it by a coefficient if it's there, and then decrease the degree by 1. Right? Most of the work is not going to be this. Like this is pretty straightforward. We've done a lot of practice. Most of the work is going to be reducing, okay, and simplifying. So recall that you can have no negative in general. Even though the back of the book answers will have some of this, I want you to practice kind of the more common expectations. So you don't want to have any negative exponents in your answers. Convert them to positive exponents by moving from top to bottom or bottom to top. Right? And we don't want to have any fractions in our exponents. We want to convert those to radicals. So no fraction exponents. Okay? And lastly, we don't want to have any radicals in the denominator. Same thing as always. And the denominator. So if you see something that has an answer and it has like to the something like that, we need to convert that to 1 over x squared to make it a positive, right? If we have something like, let's see here, x to the 1/4, right, we need to convert that to the 4th root of x. And if we have something like, I say 1 over x to the 2/3, right, we need to simplify that so it does not have a fraction or a radical denominator. There's going to be 2 steps. We'll go over that in a little bit of what that looks like. So a lot of little things. Most of your work is going to be about how to simplify it properly, not so much about the derivative part. Okay? So good practice. So here we go. Let's look at a few. First one. You could probably already do this. There's nothing tricky about it. You already know all the rules. So just make sure you start off with denoting that it is derivative by putting g prime of x and then equals. Don't just put equals and then the derivative, but explicitly say that's what it equals. So we'll have -2 times x, and we'll decrease the exponent by 1. Right? We'll just take it down by 1. That's not a step you actually need to show, but I'm just showing it for today. So that's x to the -3. And then ask yourself, is there anything about this form of the answer that's not following this set of rules? And of course, this one would be no negative exponents. So since this is negative right here, you want to keep on going and simplify further. Okay. So rewrite it as a positive exponent. And we could join these together, just multiply the tops together. So this -2 times 1 is just -2. And then the bottom is just the bottom. And that would be a nice, fully simplified version of this answer. Note that x on these, we don't really need to put this, but just note that x cannot equal 0. We have asymptotes and things like that. It's not necessary to put this, but once you start getting into these types of functions, these are rational functions. Those are the ones that had all those asymptotes and everything. So you run into some issues down the road, which we'll look at some of it graphically, but not a whole lot. You'll see most of it next year. All right, so another one. Moving on. So this is already in the exponential form that we're used to having it in to do the derivative. So if it's not in that format, like over here, do a little work to put it in that format. So we're basically going to do the reverse of what we just did right here. If it's in this format, we can work backwards and rewrite it as x to the -3. Okay. All right. So take that 4 and rewrite the over x to the 3 to x to the negative 3, because we moved it to the top. And then we can go ahead and find the derivative. Note that I didn't put f prime equals because I'm still just changing what f of x equals. So make sure you start denoting that at the proper time. So now we're finding the derivative based upon this format. So we'll get, let's see here, negative 3 times 4 times x to the negative 3, and take that down by 1. You do not have to write this part out the way I'm doing it. You could just jump to the answer if that's clear for you. And of course, one more time, the negative exponent moved down to the bottom. Okay. Good to go. Next. All right, let's keep going. Last one. This is pretty much straightforward. It's already in the proper format, so we can take the derivative pretty quick. Try that one on your own just to make sure you can do it. So we'll have 3 times negative 1 times x to the negative 1 minus 1. Negative 3 x to the negative 2, which is negative 3 over x to the 2. All right, so let's moving over to something a little more challenging now. Let's step it up a little bit. So definitely this is not in the proper format, right? We need to expand this out. That means we need to multiply this by itself. So we need to do x to the third minus 1 over x squared and just multiply it by itself. Okay. And do the expansion. Get rid of that 2 right there. There we go. And we want to multiply these together. Now, we should be, if not already there, good at expanding these without doing like boxes, box methods and stuff like that and drawing squares. But just knowing that there's a pattern here, that it always comes out to be a squared minus 2ab plus b squared when we're doing this type of expansion. Right? It always follows this pattern, right? Because we have to multiply these two. Right? That's what a squared is. We have to multiply these two. That's what the b squared is. And since these are both minus, it's going to be plus. But this minus 2ab, right? Why is it 2? Well, it's because this times this is the same as this times this, right? Those are identical. They're both x to the third times negative 1 over x squared. So we don't really need to write out boxes and stuff like that. Just follow the pattern. So we have a squared, which is going to be x to the third times x to the third, x to the sixth, minus 2, and then our a, which is x to the third, and our b, which is 1 over x squared. Right, and then once again we have the b squared, which is negative 1 over x squared times itself. So it's going to be plus 1 over x to the fourth. So it requires quite a bit of simplifying here. Right, so we got simplifying here as well. We got this x squared, and that can cancel out with 2 of those. So really this comes out to x to the sixth minus 2x, and then when we want to take the derivative, so rewrite this as a negative exponent, x to the negative 4. So quite a bit of little work to get it ready to take the derivative. There's going to be other methods for doing this, by the way. The fact that it has an exponent, there's different properties which we'll learn down the road that will give you the same answer, but this will work just fine for now. So now that it's in the proper format, now we can do the derivative, g prime. And just go through each one by one. All right, derivative of that, 6x to the 5th. Derivative of negative 2x is just minus 2. And derivative of x to the negative 4. So minus 4x to the negative 5. And then one more step just to simplify the negative exponent. Rewrite it one more time as a positive exponent. Minus 4 over x to the 5. Good. So I wouldn't say difficult, but yeah, a lot of little steps that definitely are prone to error if you're going too fast or not writing big enough or writing too small, that kind of stuff. All right, so that's the first part, all negative exponents. All right, also known as rational functions because negative exponents are just fractions. That's what they mean, small fractions usually. The second part are the rational. Rational just means, we got a number on the top and the bottom, something like this, x to the 3/2, which is the same as, recall, that's just the same as the square root of x to the 3rd. So we can rewrite anything with a radical with a fractional exponent instead, so if it's not in this format, then we will have to convert it, right? So just remember, square root obviously means that's a 2, so that's how it becomes x to the 3 over 2. So apply the power rule to start off here. Same thing. We have the coefficient coming down, so that's 3 over 2. We have our variable with our exponent, and we're going to subtract 1 from it. Okay. So what is 3/2 minus 1? What is it? 1/2, right? So if you're looking at 3/2 minus 1, you're like, oh, I'm not sure, I got a comment or not. You want to speed this up, right? This is just 1.5 minus 1. 1.5 minus 1 is a half. It just should be a quick thing by now. So if it's not, start practicing getting better at just doing fractions quickly and accurately, right? But we don't want to make any of all this. You don't want to make a mistake on just subtracting fractions. All right, so almost there, but we have a fractional exponent, which we don't want to have, so no fraction exponent. All right, so rewrite that as a root. So we got 3 over 2, and x to the 1/2, of course, is the same as square root of x. And lastly, we could combine this all the way together and say it's 3 root x over 2. Just make a single fraction instead of a coefficient and a radical. All right. All right, so next, kind of like before, the first one is set up properly. Ready to use the power rule. This one is not. How can I convert this so it is ready to go? What will this equal? X to the 1/4. Good. And then just go from there. So go ahead and pick that up. Go ahead and see what you get. Start off with f prime of x and go from there. So 1/4 minus 1? Negative 3/4. All right. This over here. So I should move this, since it's negative, move it to the bottom, make it positive to satisfy the no negative exponent rule. So let's do that. So we're going to equal 1 over x to the 3/4. No, 4 times x to the 3/4. Like so. All right. Now, recall that x to the 3/4 is the same as the 4th root of x to the 3rd, right? And we don't want radicals in the denominator. So if I switch this to here, then I would not be following this last rule. No radicals in the denominator. So we got to do a little trick ahead of time before we convert it to a radical. So what is the nearest whole power to 3/4? Just to 1. And what would I need to add to 3/4 to get to positive 1? 1/4. So I'm going to multiply top and bottom by 1/4. Or x to the 1/4, I should say. So that right there is a crucial step to know, why did I just choose 1/4? Could you explain that to somebody? It's really a working backwards thing, because I want this to be a whole number, and whatever number this is, there's a certain amount you can go up to get to the next whole number, whether it be 1, 2, 3, or 4. But I just want to avoid a fraction altogether. Avoiding a fraction is the same as avoiding a radical, right? And that's our goal. So if I just choose x to the 1/4, right, on the bottom, I'll now have 4x to the 1st, right, which is just 4x. No fraction on the bottom, no negative exponent on the bottom, no radical on the bottom. And on the top, we just have x to the 1/4, which is the same as 4th root of x, like so. So that would be our most simplified answer right there. So as long as you know why I choose 1/4, you'll be good to go. Okay? Otherwise, it can get a little confusing. All right. So now you know about that trick to help us avoid the radicals in the denominator. You can use it whenever you need to. Okay. Lastly, we got this one. So what should we do first? Yep. Close. Yeah, let's just change everything to fractional or to exponent form first. So let's make this right here, this 1/2 root x. Let's make everything an exponent before we start doing anything, right? Because the derivative power property relies on everything being an exponent. So x to the 1/2. Yeah. So now go through and distribute. So x squared times x is x squared. I mean, x squared times 1 is x squared. X squared times x to the 1/2 equals. Here comes fractions again. 2 plus 1/2. 5 halves, yeah. So we have to know 2 1/2, 2.5, right? That's the same as 5, half of 5. 2.5 is half of 5. Same thing. So I guarantee of all this calculus and all this stuff, it's the fraction work that will trip people up. So have a calculator handy if you need it, just to make sure. If you're not getting the right answer, go back and check that first. Then we can go ahead and do some derivatives. So we got h prime of x. Go from there. Derivative of x squared is just 2x. Derivative of x to the 5 halves is going to be 5 halves. x to the what? 3 halves. 5 halves minus 1. Right, if we want to write that in there, all that is just 5 over 2 minus 1, or minus 2 over 2. Right? So 5 minus 2, that's where the 3 halves comes from. Okay, what's next? So there's a little rule for reducing fractional exponents. If the top number is bigger than the bottom number, you actually want to break them up. So think about this as the 1.5 power or 1.5 power. And we can break this up into 5 over 2 times x to the 1 times x to the 1/2. So really I'm just looking at 3 over 2 and thinking of them as 1.5 or 1 plus 1/2 and breaking it up. It's just simplifying it a little bit more. So this way we get the most simplified answer possible. So we'll just get x to the 1, which is just, well, x, and then x to the 1/2, which is just square root of x. So if we didn't do this, we would have had the square root of x to the 3rd, but that's just not fully simplified. So one more time, if you look at this and you see the top number is bigger than the bottom number, that means the answer is bigger than 1, right? When the top is bigger than 1, this is 1.5. Break it up to a whole number plus some fraction, and then simplify. That will be fully simplified. So between this rule right here, knowing how to simplify these fraction exponents, and then up here, knowing how to rationalize when you have a fractional exponent on the bottom, how to get to the next wholest number. Both of those are going to be crucial. There's small little details that you may or may not have learned in Algebra 2, but we need to practice those and be ready for those. Because I guarantee when you're doing integrals and other things like that, the simpler answer you have, the easier it is going to be to do calculus stuff with it. All right, so we got an all-odd homework. Some of the answers still have negative exponents. Go through and make them positive exponents and follow this anyway. Remember, this book is kind of old, from 1988, so it wasn't necessarily as strict as some things as others. So we want to make sure we are following this regardless of what the back of the book has. All right, there you go. Got some time to work on this, and then you got some time on Friday. So plenty of time to get all caught up and done.